In this video, I'm going to showcase how to solve word problems that arise from periodic functions or sinusoidal functions. Specifically, we're going to discuss how to find the output given the input or vice versa. This first question asks us to find two things. Let's read the question first. The average volume in lungs, measured in milliliters, when a person is resting is given by this equation. We notice that it's using cosine here, where m is the time measured in milliseconds. Question A, find the average volume, so find the output volume, V, in the lungs after input, which is milliseconds, 200 milliseconds. So we want to input 200 into the equation wherever m is. So here's the equation, and this is the spot where m was. We're putting 200 inside. Then we're going to work with the inner bracket first, so subtracting the inner part, and then multiplying gives us a 70-degree angle inside of cosine. And then in order to evaluate further, we want to find the output of cosine, then multiply it by 250, and then add this outer number to it. So if you do that on the calculator, you'll get approximately 2,836 milliliters. And whenever you're dealing with word problems, don't forget to do a therefore statement so that you're not losing any marks. Part B says we need to find at what times, notice it's plural, during the first cycle is the volume in the lungs at this level, 2,600 milliliters. So this time we're giving the output volume, so we're going to plug in V equals 2,600 into this equation as before, and our goal is to solve for this m. There are two ways I'm going to demonstrate how to do this. One method will be purely algebraic, and the second method will be partly graphical. So either ways, whichever way you'll be comfortable with, you're welcome to use either one of those. So for algebraic method, I prefer to make this input of cosine to be a very simple angle that I'm going to call theta. And rewriting this equation makes it much easier to solve for the theta first. So from this line to this line, we have subtracted 2750 from both sides and got this result here. Then I need to get rid of 250, so I'm going to divide both sides by 250 and get this result. Now, we can find out the angles theta by using cast, which, as you recall, represents that cosine is positive in this quadrant. Well, for us, cosine is not positive ratio. It's actually a negative, so we know our answer won't be in this quadrant. A stands for all ratios positive here. Well, that's also not going to be working for us, so our two values of potential angle thetas would be in quadrant number 2 or 3. Now, for me to draw this more accurately, I want to actually know how big is the related angle. So in order to find the related acute angle, you can drop the negatives on the ratio and just do the cosine inverse. When you do that, so it's just cosine inverse of positive 0.6, you get approximately 53 degrees. So now we can more accurately represent this picture, having in this arm 53 degrees near the x-axis, don't put it near the y by accident, and then near the x-axis in the quadrant number 3 as well. Then the step is to figure out the actual rotational angle, because theta r, or related acute angle, is not our true angle solutions. This is just a rough work to figure out the final theta value. So in order to find this spiraling angle, what I have done is I thought of this straight line right here. Straight line is 180, so I subtract from 180 53 degrees, and that's how I found theta 1. The next spiral from 0 degrees, by the way, this line right here is 0-degree rotation. So if it went like that, I need to take, again, a straight line, which is 180, and then add 53 degrees to get my theta 2. Then, because my original question never had theta, so it was m, which represented time in milliseconds, I need to replace back what I substituted. So theta is equal to 2 degrees multiplied with m minus 165. I'm going to use this equation and my two answers, 127 and 233, to find out the corresponding values for the milliseconds. So here are the two versions. So to find using theta 1, we'll find m1, and using theta 2, we'll find m2. So theta 1 is 127, theta 2 is 233. Then what we can do is divide both sides on this equation by 2, as well as on that one. To isolate m1, we need to add 165 to both sides. Same thing on that one. And we get m1 is 228.5 and m2 is 281.5. Now we're not done, because it did say in the question we want the first cycle. So we don't know how long the cycle is until we do the period calculation. So the period calculation, as you would have studied already, is 360 degrees divided by the k value. And by the way, if the k value is negative, drop the negatives, because period is never negative. So technically that should have had absolute value there on the k. Anyways, for us, k is 2, so 360 degrees. Notice I'm writing degree here, and the 2 had a degree symbol, so there's the 2 degree symbol here too. And the degrees will actually divide out, so it will be just 180 without a unit here. So this unit actually will be in time now, instead of just degrees with time. It's just time now, because degrees will cancel. So the period is 180. So the first cycle is from 0 to 180, but these numbers are way beyond that. So it's not within the first cycle. So this is what we're going to have to do. The way I think about it is I create one list from the first m1, so the time that we found for millisecond, number 1, which is 228.5, and then add or subtract period to get an infinite list. So if we add 180 to this one, we get even further down the cycle, which we don't want. But if we subtract 180, this would be within the first cycle. So that's one of the answers we'll be using. Then you do the same thing for the list for the second answer, for the time that we found. And adding or subtracting 180, this is beyond what we want, but this first one is again within the first period. As you can see that it's lower than the actual period 180. And this allows you to answer the question. You would say, during the first cycle, volume is 2600 milliliters at, and then you specify the 2 specific times that we found within the first cycle. So this is one method of doing it. I'll leave it there for comparison for method number 2. So method number 2 starts algebraically first. So the first line that we had here, 2600 equals, and then this line, it's the same thing here. But unlike the algebraic method here where we found theta by doing a replacement, let's say you were just going to isolate for m. Let's say you forgot that you can simplify the equation to look for theta 1, theta 2. Let's say you just proceeded to isolate for m. Now recall, when you're isolating for a variable, you're doing BEDMAS in the backward order. So if there is any adding or subtracting outside of the bracket, that's what you want to get rid of first. So this subtraction right here is inside the bracket, so you don't touch that yet. But this addition is not captured inside the bracket. So this is the first thing you're going to undo by subtracting 2750 from both sides. So that kind of looks like what we've done before. Let's continue. So then to continue undoing, we need to look for any multiplication or division that's outside of the bracket. So there's multiplication here, but it's captured inside the bracket, so don't touch that yet. We need to get rid of this multiplication. So opposite, or to undo multiplication, you need to divide. So dividing both sides, we get this. So just like we did before, that part didn't change. Now let's proceed. In BEDMAS, the e represents exponent, but keep in mind the exponential functions are not the only ones we're working with. Right now we're working with trig functions. So the position in BEDMAS, the e position, is actually applying the function. All right, so here we want to undo cosine. So to undo cosine, you're going to do cosine inverse of both sides. And we're not going to go with what we did here by dropping the the negative to find the related acute, because here we were doing the method of drawing a picture and looking at symmetry. Let's say you forgot all of that. You're just going to just undo every single part. So we're going to undo cosine inverse here with the negative as it stands. It's fine. And we get 127. So notice you get actually one of the angles right away. So you might prefer this because you get an angle that you don't have to do symmetry on. Then, because we have, so notice this line right here had an extra bracket. That bracket did not hold anything, so you can actually remove that outer bracket, and that means we basically restart SEMDIP from beginning, because at the end, B stands for bracket, so once you dissolve that bracket, you start from beginning. So right now, this is still within the bracket, so we cannot touch that, but we can get rid of this division or multiplication of 2 by dividing. So you do that. That dissolves this inner bracket, so now it's no longer there, and then you get rid of the negative 165 by doing addition of both sides by that number. And you get your value that we had before over here. Now, at this point, you might reread the question and say, well, because we want to find multiple times within the first cycle, you might say, oh, I'll just add the period or subtract the period. However, the values you would get are going to be on this list, and you'll notice that one of the numbers is within the first cycle, but then the next one up is not within the first cycle. So adding or subtracting the period will never give you these values here. And that's why the solution has to be partly graphical. If you do just this is not enough. So if you don't like graphing, I would suggest you actually follow what I did on this side. But if you don't mind sketching a graph, then this might be a good method for you. So in order to sketch this equation, I'm going to remind you of what we learned before. This last number out here that's being added outside of the cosine is the axis or the average value of volume. So you can sketch a dotted line and label it. Then the amplitude comes from the A value or the multiple outside of the cosine, just ignore any negatives on it. And the amplitude is 250. So you're going to add 250 from this axis and subtract 250 to get your maximum value and your minimum value. Sketch the dotted lines for those. Then this number on the inside that's added or subtracted inside the input, that's your phase shift or shift left or right. So because it's negative 165 inside of the equation, then that phase shift is actually positive 165. Next, I told you guys to memorize 2 sentences. One sentence was for cosine, and the cosine sentence to memorize was cosine starts at maximum. And for sine, by the way, just a little note, even though this is not our question here, sine starts at axis and then goes up. All right, so this is the parent shape that we're going to be sketching, but we're going to do it within these dotted lines as our shape. So I'm going to put in 165, more, not at the end here, at the edge, but closer in, because I know that this value that I found here, this is not within the first cycle as you saw before. So I'm going to give myself more space to go backward to have the first cycle visible. So let's say this is the first cycle and we're putting it on the very top, because at that position, the start of the cosine wave will be at maximum. Then, as we already calculated before, period is 180. And so if you add 180 to 165, you would get this result. And so we know our shape for the wave is going to come back to the same spot after the period. Then in order to find this middle number, we can just do the average of the outer ones. So right in the middle, the wave will come straight down to the minimum. And a quick reminder about the letters. So if we call this one letter A, this one K, this one D, except it's going to be positive, and this is C, then the axis comes from the C, amplitude comes from the A, except with you ignore the negative. The phase shift will be D, except switch the sign of what you see in the equation, and the period does not appear in the actual equation. It is related to the k, but it's not the k itself. It's always a formula that you follow, 360 divided by k, and so for us it's a division by 2. And so just a quick note, where did this number come from? That comes from the d. This number over here comes from d plus period. This number in the middle is that one and that one added together and then divide by 2. Make sure you press equals before you do division by 2, because you want both of the numbers to be added or divided by 2 here. And so this is how I found this 255. Next, we can find the middle of 165 and 255 by doing the average between those two, and that would be where the cosine graph will cross this axis line. And then same thing on the other side, find the middle of those two to find this 300. Then when you're drawing it, make sure you do curves. So don't just draw a straight line down, straight line up, even though these points look like they're creating a straight line. It's going to be a wave. So imagine there's like a circle over here that you're going to go around, and then a circle down here that you're going to go around back up. So I would draw these in 4 different strokes to make sure it actually looks like a wave-like pattern. Then, because we were talking about this first cycle, I'm going to take my d here and subtract period from that, and you get negative 15. And so that's going to be, again, where the maximum will occur for this equation. And then you can finish off the wave. This is the second cycle now. Now, let's go back to the question, because it says at what times during the first cycle is the volume at 2600 level? So 2600 will be higher than 2500, which is our minimum, but not as high as our axis. So I just eyeballed and did a dotted line through there with a different color. The answer that we found, you place it on your picture. So looking at 228, well, we know it's bigger than 210, but it's not as big as 255. So it must be this point where the graph intersects this line, 2600. Then what I would do is find out what is the distance of time between the point that we have found and this minimum. So if you subtract 255 with 228.5, you get 26.5. And we know by symmetry, to get to this other point right here, it would be exactly the same amount outwards. So if you were to do that, you would get this value here, which, as you can see, is the value that was found over here. So here we were doing it using symmetry on the quadrants and just using our last unit of rotational trigonometry. Here we're using the symmetry of the actual curvature of the wave. So we got this value now, and these two values are 2 times within one cycle, except they're not in the first cycle. So the next step to do is to subtract from each one of these the period to get our values. And that gives us this value and this value at the same time. So this is the second way of doing it. Let's do one more question where we'll concentrate only on finding equations. We won't solve them right now, but it is a skill to be able to be given word problems and then create an equation. The previous question, the equation was provided for you. Let's practice creating the equation using sketches. So we're going to do 2 things here, 2 different questions basically. One of them will be height versus time, and the other one will be height versus distance traveled. So we're told the wheel with a diameter of 10 meters whose axle, so that's this the point where upon which the wheel rotates around. The axle is 7 meters above the ground. The rotation is occurring once every 9 minutes. And we need to find the equations. Notice plural, so I'll actually do several versions of equations for each one. So first of all, this information axle. This axle is actually, just think about it, that is also the axis or the average value for the height. So I'm going to do a dotted line, label that with 7. Then we're told diameter. Diameter is 10. That implies that radius must be 5. The radius relates to the amplitude, so we can go up 5 and down 5 for our maximum line and minimum line. Next, you're told that you're starting at a minimum. So we have the 0 labeled here, and we'll have a dot right here in a moment that will put in that the cycle will begin at the minimum. So here is the points, and because it begins at a minimum, I just, right now, without labeling these, I just went equal distance to the side so that I can go up, up, down, down, and use curvature as you connect these points, as I discussed before. So this, technically, the picture is finished, except on the bottom. We need to have 5 labels for the cycle horizontally. We have 3 labels vertically, we need 5 horizontally. And so in order to do that, we're going to use this piece of information. You're told that it rotates once every 9 minutes. That tells you your period is 9. So if it starts at 0, then up 9 is the edge here. Then to find the middle, you do half. And then to find the middle of that one, half again. And then to find this one right here, you just do this plus that divided by 2. Now, another way to find these values, in black right here, is to take your period, which is 9, and divide it by 4. Why by 4? Well, because we have 4 chunks within a cycle that even we draw. So this is 1, this is 2, this is 3, this is 4. And so each one of these has a length of 2.25. So you can start from 0 and add 2.25 to get here, add 2.25 again to get this one, and continue this pattern until you reach 9. So there's 2 ways to find these black numbers. Remember, every cycle, I would like you to label 5 points horizontally and 3 points vertically. And so to create the equation now, it's important to create your let statements, what the variables represent. So I'm using h and t, h for height, t for time. And I'm specifying what units I'm going to be using as well. And so when you're creating equations, it's going to follow this format, and we can have a sine or a cosine for the function itself. Then from the picture, we can see that the amplitude size here is 5. We know that the axis is the 7. And we know that the k is related to the period by this equation right here. So the equation that we had before was 360 divided by k equals period. But if you reorganize the equation, you'll get k equals 360 divided by period. So in this situation, if we take 360 divided by 9, notice how there is a degree symbol on 360. Don't lose it. We still have 40 degrees. Okay. Notice how I put in k here is potentially positive or negative, but I prefer to just put any of the reflections that I need on the a value. So I always use a positive on the k when I'm creating an equation, just to make it life easier for myself. Then let's recap the 2 sentences I told you guys to memorize. Cosine starts at, and sine starts at, and goes where? Okay, so cosine starts at maximum, and sine starts at axis and goes up. Those 2 sentences are for the parent function, or when we have no reflections in the x-axis, meaning a is positive. And so if I were to find out what is the d value, so this shift, okay, is where the cycle will start horizontally. We can say that the cycle could start right here, and so the d could be this value 4.5. Don't grab the 12 by accident, right? Because this point maximum has 2 values associated with it. It has the 4.5 and it has the 12. So just because we say cosine starts at maximum doesn't mean we take the value 12. We take where this value occurs, because d represents shift left or right. So we need to grab the horizontal number 4.5. So if we're going to use positive on the a, we could use d is 4.5. Or we can say, because sine starts at the axis and goes up, we could say d is actually over here, because this is where sine would have usually began at the axis and then goes up. So we could say d is 2.25, and notice again, I'm grabbing this horizontal number, not the 7. Now, if we wanted to, we could create equations with a's being negative. If you use a as negative, then cosine will then start at minimum, and sine, instead of going up from the axis, it will go down. So let's do those variations as well. So I could use d is 0 if I use cosine with a negative a. because this is where cosine begins at the minimum. So you pick the minimum value. And notice again, I'm using 0, not 2. Or I could also use this number, d equals 6.75, if I use sine with a negative value on the a, because this is where it begins at the axis, but then here it's going downwards, not upwards. And so these are my equations then. 5 comes from the amplitude, 7 comes from the axis, the 40 comes from the k here that I calculated from the period. Do not lose that degree symbol, because without the degree symbol, it's going to actually imply it's all in radians, which is in grade 12. So I'll put that degree symbol in there. And then because I'm using d here, the 0, and I said cosine is negative, this should have a negative for it to be true. So just because you use 0, make sure you adjust what your a value has to be so it actually matches your d. Okay, so here's that negative fixed up now. And then if I wanted to use this value right here for 2.25, then d would be the 2.25, and this is for sine. So notice I have changed my equation to sine, and I'm using a positive on the a to match that. Another version could be to use this 4.5 as the d, but to match this, we have to use cosine, because cosine starts at maximum. And notice positive is used on the a value or 5 value here. And lastly, if you wanted to use this value for the d, then make sure you use sine with a negative value in front. So this is part A done with 4 different ways in terms of the equations. Let's now talk about the equation that we can create height versus distance, because this is still about height. I've kept my graph as before. It still starts at minimum, and we have the y values for height identical to before. However, now instead of plotting time numbers on the bottom, I've erased them. We're going to put distance traveled values on the bottom. And so in order to find the distance traveled, I'd like you to imagine taking the circle, the circumference around the circle, and unraveling it. So here it is flat, and I will actually just move it to the edge here. So if the circle was actually traveling along the, let's say, a road, then this length right here will represent the distance traveled by the point on the rim of the wheel. So this distance traveled is circumference, okay? And it is distance traveled within one cycle. So that will be our period as well. So the radius, as we know, is already 5, and then we get 20 pi meters. Do not change this to a decimal, leave things precise. So period is 10 pi, and so you can place that on the edge for your last value from 0. Then right in the middle would be 5, in the middle of that would be half of 5 pi, and right here would be 15 pi over 2. Then you create your let statements again. I'll keep my h for height, but this time for distance traveled, I'm going to use an x. All right, so just like before, the same setup. The amplitude stays as 5. The axis stays at 7, but the k value changes. The k value is 360 degrees divided by the period, which is 10 pi. So when you reduce 10 divided by 10, you'll have 36 degrees over pi. And then for this one, I will do d equals 0, and I'll use cosine with a negative a, because this is where cosine starts at minimum instead of at maximum. And so this is what the equation will look like. I'm using 0 for d, negative on the a to match that. This is my k. Don't lose that degree symbol on the 36. It is important. Now, in grade 12, you will actually learn how to create these equations so that you're not writing anything in degrees anymore. So to eliminate writing this degree unit in equations, you can use radians. So let me give you a preview of what you would see in grade 12. Pi radians, so 3.14 roughly, is a value for the pi. It is measured in radians, or actually radians is not truly a unit. You'll learn that in grade 12, but that's equivalent to 180 degrees. So if you were to replace the pi value, so over here, this 36 degree divided by pi, you can actually change this pi into be 180 with a degree symbol. So then degrees will cancel out. and 36 reduced with 180 will be 1 over 5. Doing this will give you this particular equation that looks a lot more simpler than what we have here. And notice this equation doesn't have any degree symbols, and that is a clue to whoever's reading that the measurements being done here are done in radians instead. Just a quick reminder that the formulas we've been using for K relationship with period in grade 11 is 360 degrees divided by P, but 360 degrees is equivalent to doubling 180, so that means we double pi. And so you might have seen the formula 2 pi over P, and this is what you would be using in grade 12.